now I'm going to go ahead and find out what is this angle right here inside that little triangle, which is also sharing the vertical angle with this angle inside the larger triangle here. We're going to need that in a minute, you'll see. So in order to find this angle here, I need to take the tangent of that angle. So, we want to find this angle right here. And in order to find this angle, we've got that the tangent of theta is equal to the opposite side, so 3 meters over the adjacent side. So we've got 4 meters here. And so then my angle theta is equal to the inverse tangent of 3 over 4. And so then turns out that this angle is 37 degrees. So this angle right here, 37 degrees. And because it's a vertical angle with this angle right over here, this angle there is also 37 degrees. So now, using that angle, we can now go ahead and get the components, x and y components of F13. So if we use this angle here and think about cosine, we've got that the cosine of this angle in here is equal to the adjacent side over the hypotenuse. So is equal to F13, x component, divided by the magnitude of the hypotenuse there, or the magnitude of my vector F13, okay, which we know to be 1.08 times 10 to the minus 8 newtons. So this says that F13x is equal to the magnitude of F13 times cosine theta, so cosine of my angle here, 37 degrees. So if I put in 1.08 times 10 to the minus 8 newtons cosine my angle 37 degrees, then I get that F13x is equal to 8.63 times 10 to the minus 9 newtons. Okay. So I will put a box around these values here. So then I've got that F13x is equal to 8.63 times 10 to the minus 9 newtons. It's positive because F13x is pointing in the positive x direction. Okay, positive. And then in order to get F13y, I do a similar thing, but instead of using cosine, now I'm going to use sine. So the sine of this angle inside here, sine theta, is equal to the opposite side, which is F13y, divided by the hypotenuse. Sine is equal to opposite over hypotenuse. And so then I'm going to divide it by the magnitude of F13 here. Okay? So then I get that F13y is equal to the magnitude of F13 times sine of my angle 37 degrees. So the value F13y is equal to 1.08 times 10 to the minus 8 newtons times sine of 37 degrees. And so then F13y is 6.50 times 10 to the minus 9 newtons. Also positive because this component of my vector is pointing in the positive y direction. Now I've written our x and y components of F23 and F13 over here on the side. And now we're going to sum them up together in order to get F3x and F3y. So if you take the sum of here for F3x, if you take the sum of F13x plus F23x, then you get F13x plus F23x. Then you get that F3x is equal to 3.01 times 10 to the minus 9 newtons. And for F3y, if we take the sum of F13y plus F23y, which is actually 0, then we get over here that the component F3y is equal to positive 6.5 times 10 to the minus 9 newtons. Okay? So now we can take F3x and F3y, plug them up in here to our equation for the magnitude of F3y, and whenever we do that, we get that the magnitude of F3y is equal to 7.16 times 10 to the minus 9 newtons. And I'm going to go ahead and put a square around that because that's our magnitude of F3. But we need the direction because vectors actually have both a magnitude and a direction. So what I'm going to do is I'm going to erase what we've got written right here. Okay. And I want to look again at my charge Q3. On Q3, we've got F23 pointing off in the negative x direction. We've got F13 pointing off in this direction here. And now we've got our component, our vector, the resultant vector, F3. And it has an x and a y component. It has an x component 3 times 10 to the minus 9 newtons, a y component of 6.5 times 10 to the minus 9 newtons. So if I kind of draw what that looks like, maybe it's going to sit somewhere right in here. So we'll call that F3. Okay? It's got one leg that has a length of F3x, one leg here, that's F3y. Okay? So we know those components. We can get this angle right here, the angle at which my vector F3 is from the positive x direction, from the positive x-axis. To get this angle here, which I'm going to call alpha, we can say that the tangent of alpha is equal to opposite, which is F3y, over adjacent, which is F3x. Okay? And then the tangent will be, the angle alpha here will be the inverse tangent of this side. And if you do that, we get that alpha is equal to, so take the inverse tangent of F3y over F3x, you get that alpha is going to be equal to 65.1 degrees. So now we have our magnitude and our direction. So our force on particle 3 from charges 2 and charge 1, the resultant of that force, the sum of those forces from both of those other two charges on charge 3 is going to be equal to 7.16 times 10 to the minus 9 newtons. That's the force, and it's at an angle of 65.1 degrees. So the sum of all of those forces from those two charged particles acting on particle 3 will end up with a resulting force that is pointing off in this direction here. And so if we release the system, this charge here is going to be accelerating off along that vector in this direction right here. So that's how we can find the magnitude of a force acting on a particle in a fairly complicated electrostatics problem.